Hi, this is Alex from devstories.eu. OpenCV, Computer Vision Deep Dive, Episode 1 of 20. Most developers think of an image as a compressed file sitting on a hard drive, but the moment you pass that file to a computer vision library, it sheds its file format and becomes a massive grid of numbers waiting for matrix math. Understanding exactly how those numbers are structured is the soul of OpenCV. Pixels as matrices. When you load an image using OpenCV, the read function pulls the file from disk and instantly converts it into a multidimensional NumPy array. This is the part that matters. OpenCV in Python does not use a proprietary image object. It relies entirely on NumPy. Because an image is just a standard array, every mathematical operation you can apply to an array can be applied directly to your image. Let us look at the structure of this array. If you load a standard color image, you get a three-dimensional matrix. The first dimension is the height, which represents the number of rows. The second dimension is the width, representing the number of columns. The third dimension holds the color channels. If you have an image that is 800 pixels wide and 600 pixels tall, your array shape will be 600 rows, 800 columns, and 3 channels. Each intersection of a row and a column holds a pixel, and for standard images, each color channel inside that pixel holds an integer value from 0 to 255, representing the intensity of that color. There is a very common trap here. Most graphics software and web browsers represent colors in the red, green, blue format, known as RGB. OpenCV does not. For historical reasons dating back to early camera hardware, OpenCV stores color channels in the reverse order, blue, green, red, or BGR. If you try to display an OpenCV image in another library without swapping those channels, your reds will look blue and your blues will look red. It's not a bug in your code. Just remember that the value at channel index 0 is blue, index 1 is green, and index 2 is red. Because images are just NumPy arrays, manipulating them relies on standard Python syntax. You do not need specialized OpenCV functions to crop an image. You just slice the array. Suppose you have a high-definition security camera feed and you only care about a 100 by 100 pixel region where a door is located. You extract a region of interest, or ROI, using standard array slicing. You specify the starting row and ending row, followed by the starting column and ending column. In mathematical terms, you slice the y-axis first, then the x-axis. This instantly returns a smaller NumPy array containing only the pixel data from the door. Once you have sliced your array or modified its pixels, you usually want to save the result. OpenCV handles this with a simple write function. You provide a destination file path and pass in your NumPy array. OpenCV reads the file extension you requested, such as .jpg, and automatically handles the complex compression required to turn that matrix of numbers back into a standard image file. The single most useful thing you can do when learning computer vision is to stop thinking of images as visual canvases and start treating them as coordinate systems filled with raw numerical data. If you enjoy these deep dives, you can support the show by searching for DevStories EU on Patreon. That's all for this one. Thanks for listening, and keep building.